attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning to everyone. Nagarjuna from Suryahana Academy. So, we, so we're going to start today's session. So let me recap what we have seen in yesterday's session. Yesterday, we discussed about replication. Replication is mainly used for frequently changing data scenarios, especially for transaction data. When we replicate a table, DB triggers logging tables are created. DB triggers monitors for any change like insert, update, delete on the table. And logging table is also known as a queue table. It's a temporary storage area. Especially when we do suspend, data is temporarily stored in the logging table, and when we resume, data is released from logging table, deleted from logging table, and data is available in HANA. So today we're going to start with stop. So after this we're going to see advanced application settings. So what does stop do? When we do stop activity, what happens? Let us see. So let me log into remote desktop. Let us log into HANA Studio, also to SAP GUI. Okay, so this is a source system. So there is a connection between the source system to the SLT and SLT to HANA. So when we execute a stop, logging tables and DB triggers are deleted. So whatever the changes that you make on the base table, these changes will not be reflected in HANA. And permanently, these tables are deleted. So when you replicate the table again, the same logging table is associated to the base table. So there is no new logging table created again. The technical name of the logging table is same. When we replicate again, so you can stop and replicate again. So you'll have the same technical name for logging table. When you stop, the table is still available in HANA. So when do you stop? For example, when a business requirement is changed and you no longer require to replicate table from table. You want to use a different table. We stop replication. So let's go to LTRC. Let's go to LTRC. Click enter. So let us click on configuration. So I think yesterday configuration is deleted. So I'll use this new configuration, which is SVS SLT 2016, which is 142 is the mass trans 152 is the mass transfer ID. For example, I'll click on data provisioning. Let us go to SE11. Let me go to SE11. Let's find this table. Jet CE1 COPA table. I'll provide the table name. So basically, first I need to do start replication. Then we're going to do stop. So first, let me execute this start replication. Table scheduled with action start replication. So the schema name is SVS SLT 2016. Go to HANA. Click on the modular perspective. Click on the modular perspective. Expand catalog. Let's go to SVS SLT 2016. Let's go to the tables. So here we see Jet CE1 COPA table. Right click, open data preview. Open data preview. So now the status of the replication. So this is the table, window, show view, quick view, data provisioning. Select the system. SVS SLT 2016. So here we have the table Jet CE COPA table, replicate in process. Please see the status here, replicate in process. But the table is available here. Now, table is available with data. So I'll go back to SLT, refresh. So the login table here is 612, 612, and then DB status is activated. So let's copy this logging table. Let us copy this logging table. Let us copy this. Let me create session SE11, provide the table name and click display. So we're basically seeing the logging table. Click display, click contents. So this is the logging table. Number of entries are 0. So one point I would like to highlight here is, where are DB triggers created? DB triggers are created in the ABAP application layer or in database. DB triggers are created at the database layer. Triggers are not available in the application layer. And one more question I would like to highlight. Can you have mass transfer ID specific to a table rather than specific to a configuration? We cannot have. These are 2015 certification edition questions. Just as and when I get some, I'll discuss. So, can you have a mass transfer ID allocated to a table, a single table, rather than allocating to a configuration? We cannot allocate. We only can allocate to a configuration. So DB triggers are activated, and triggers are available as a part of database. And this is the logging table. So I'll click on data provisioning again. So I think we know either you can stop from here, or even you can use at the HANA Studio data provisioning, select system, click finish. Even you can perform stop replication over here. So one more question you get here. The question you get here is, can you perform transformations using HANA Studio? Can you perform SLT transformations at the HANA Studio? We cannot perform. We only can perform these 5 options. Transformations can be performed on the SLT server using the T code IUUC underscore REPL underscore content. So one more question regarding logging tables. Logging tables are created in database or in the application layer? Is logging table available on the ECC side or on the SLT side? Logging tables are always available on the source system side. Always available on the source system side. Logging tables are available on the ABAP application layer because the table is created in the ABAP layer, but triggers are created in the database layer. So when you click on stop, so here you cannot perform any transformations. Only 5 options are available. Click on stop replication. So what is the table we would like to stop? Select this table, click add. So this is the name of the table, and click finish. Once you click finish, refresh, So this refresh you have here, you can automate this. For every 5 seconds, you can start automatic refresh. So when you switch on this, every 5 minutes automatically automatically it will refresh the status. So we don't have to do it manually every time. You can switch on, you can specify the seconds, and we can switch on this interval. So now, instead of a replicate in process, the status changed to stop executed. Instead of replicate in process, the status changed to stop executed. So when stop executed, you can see both of them being deleted, and even table also being deleted from SLT. You'll not find an entry for the table in SLT server. So let us go back to LTRC. You see, you don't find this table anymore. In the 152, we don't find an entry for this table. So table is deleted. When the table is deleted, if you go to SE11, you see when I click back, click display. When you display this, what does it say? 162 does not exist. Check name. There is no object with the name in the above dictionary. So the login table is deleted and DB triggers are deleted. Login tables and DB triggers are deleted as a part of the replication process. Let us click close as a part of the stop replication. So once we replicate again, I'll click on replicate again. So before we do that, let us right click on the table and open data preview. Still we have these entries in the table. We also can see these entries in the source table. If I select this table, click display, click contents. So both the tables are existing. The table is existing in target, and even the table is existing in the source. If I create a new entry in the source table, I'm creating a new entry. I'm creating a new entry. Click save, click back. So we have a new entry with 8000 value. But when I refresh here, can you see this 8000? We cannot see because DB triggers and logging tables are not available. What is the difference between suspend and stop? In suspend, it maintains the logging tables and DB triggers. In stop, it deletes the logging tables and DB triggers. Then how will I get this change to HANA? So once we stop, either you can go for load or replicate again. The table is stopped. the entry cannot get to HANA. Either we need to replicate again. So I'll go back to data provisioning. I click replicate, find for the table, jet CE1 COPA table, click find, and this is the table. Click add and click finish. So once we finish, again we are replicating this table. Open data preview. You see the table is dropped and recreated again. Means the complete table is dropped. So whenever we stop and replicate the table again, the current table drops. It loads again, load executed. When load executed completed, in SLT refresh, logging tables DB triggers activated. You see the same logging table name 612. Again it gets the same logging table name. The status will change from load executed to replicate in process. Is changed to replicate in process. Now if you go back to table, refresh, now we see the new entry 8000 in the table. So whenever there is a mismatch of data or something which is not controlled, unable to control by you can replicate the table again. So before we do that, if you get any error during this process, for example, you see in the HANA data provisioning editor, everything is going very smooth for us, and we did not find any error. I would like to highlight one point. SLT 99.99% does not give any errors. 99.99% because it is basically replicating data in real time. It is used for real time. When you are using something for real time, if the product is not stable, we lose the usage of the product. Every time, like you see the difference between an ETL tool and a replication tool. What is the major difference here is, in ETL tool, the data is collected and scheduled in batch process. So for example, from yesterday till today, for example, there are 10,000 transactions occurred. All these 10,000 transactions are moved at the same time. All the 10,000 records at one shot it moves to target system. But SLT is not such a way. SLT, when you change, when you create, when you delete, immediately, instantly, at the same time, the data is moved to HANA. So the system balance load appropriately. When you take something at one time, there are chances that there is load on the system because you're taking everything at one time. And one more thing I would like to highlight here is, whenever you execute a ETL job, these jobs are running on the source system side. These jobs are running on the source system side, and they fetch data from source system to the target. But when you, for example, let us take BW. When you execute a job on the BW, to get data from ECC, these jobs are again running on the source system side. But the advantage of SLT is when SLT is not on the ECC system, when SLT is not on the ECC system, when SLT is a separate host, the jobs never run on the ECC. It runs on the SLT server. So either the errors may occur, especially for load balancing, when there is too much load on the system. Jobs are not sufficient, or the structures of the tables are incorrect. There is inconsistencies in the table structures. So most of the time, if you see, errors that arise is on the data reconciliation. Means every day, for example, the business raise a ticket saying that I'm expecting the net value of the sales document should be $500. But why is it showing me $100? What is the reason? Is the record not updated? What is the reason behind the user expects to be $500, but he only can see $100? So there's a mismatch of data. So most of the time, these are these kind of errors you can find, whether data from the source and data from the target is different, and sometimes tables are not replicating due to insufficient jobs in the system, heavy load on the system, jobs are getting stuck, unable to handle the capacity. So when you do proper sizing, most of the issues are resolved. But still, if you want to see any errors that occur, we can see in SLT logs. So where are these logs? Let us see, where are these logs? For example, here we see an error. In order to check for this error, we'll go to LTRC. So you see there is something called view errors over here. Click on view errors. Click on view errors. So it says no log found in the database. So let us basically check for any other table. So basically it doesn't show any errors for us. But here you see there is something called application log. Click on the application log. Click on settings. So you can sort user settings for application log display by date, by user. Click on filters. You can give the table name for which for which you can think there is an error. Let's say VBAK. Show all logs, only log with errors, only log with warnings, because we don't have any errors. So I'll take our table. I'll just take the table that we created. So let us select all logs, click continue. So here it gives very detailedly of all the process that is happening in the background. So basically these are the logs for today's date. Mode is batch processing. So these are all the different log numbers. Let us expand problem class. Double click on this. Just let us open here. Here you can see if you have any error, if you find any error out here, you can find this, you see error, warnings, and then information. For now there is no error, it's only showing us the information. But when you have any error, it will show detailedly here. And then you need to double click on this. Once you double click, it will show what is the error. And very detailedly it will tell you what is the error. So based on the error, the first thing I do is whenever we have an error, we know every day the same error may not repeat. And usually errors may not repeat. So first thing I do is I just copy this and type in Google. Without even thinking, I'll just copy and I'll type in Google. I'll just try to see what may be the error. From there, I'll start troubleshooting. I'll do my root cause analysis. What could be the error? Errors are something which we may not get, which are already we know. So every error that we get, we basically document. Frequently, so there's a document we prepare as a part of knowledge transfer. For example, today I may be in this project or maybe in a different project. So basically prepare all these errors in a document. And these monitoring activity is most of the time done in the support. After the project is gone live, we have support activities like enhancing the views based on the business requirement, monitoring of SLT jobs, monitoring of BODS jobs. So most of the time this is in support. Now whenever we are in support, usually this is in a shift process. So there is a 24 hours shift. So it depends on the client requirement. And for every error you have an SLA, service level agreement. So based on the client, an error has an SLA. So based on the SLA, we need to resolve these errors on priority. When it affects most of the business, the SLA is very high. So usually there is sufficient time. For a medium errors, you have approximately around 3 days to resolve the error, to complete to resolution. Again, in these errors, there are some errors that you can rectify. There are some errors that needs an enhancement. If there is any bug in the system, you need to enhance. We need to apply latest SAP notes in case of any bugs. So for that, we take it as a CR, change request. Anything that you want to change in the system, we take it as a change request. If there is something we can do about data, we can stop and re-replicate tables. but you're given sufficient time, and this is based on SLA. We need to resolve these errors on priority. So let us go back to the technical part. So whenever we replicate tables, DB triggers and logging tables are created. When you stop replication, DB triggers and logging tables are deleted. So the connection between the source table and the target table is lost. When you replicate the table again, the same logging table DB trigger is generated. So load is one time, replicate, continuous process of replicating data. Stop, it permanently stops the loading or replication process. Suspend, temporary halt, data available in logging tables. Resume, data back from logging tables to HANA, data deleted from logging table. Now let us move on to advanced replication settings. Excuse me. In the advanced replication settings, the important T code for advanced replication setting is IUUC underscore REPL underscore content. IUUC I'm sorry, here IUUC underscore REPL underscore content. So let me go to this T code. Let's go back. Let us enter this T code. IUUC underscore REPL underscore underscore content. Now once you enter the T code, LT replication server configuration overview. So LT replication server configuration overview is where we can perform transformations. So this is known as advanced replication settings. So here, mass transfer ID and the name of the configuration. So here you have two configurations. One is 152 and 154. My configuration is 152. Mass transfer ID 152, configuration name SVSLT 2016. Table settings, global mapping rules. Right click on global mapping rules. Here you can define the mapping of table columns or a mapping of tables. Add table, right click on table settings, add table, provide the table name, Jet C1 COPA table. Let's click continue. So once you click continue, here you see table settings. At the table settings, this is table settings. Table settings for what? For C1 COPA table. So we can individually maintain settings for each table. So by default, the table is a column store, but still you can change to replicate to row store, or you can change to replicate a table that can store history. By default, this is column store, so every table is replicated as a column store. Click on table structure. When you click on the table structure, original table structure, modification overview. We can modify tables in SLT system. So where are we modifying this table? The tables are originally available in the source system side, but a copy of this table is available in SLT. So you can make modifications to this table, and this is known as, in the SLT, yesterday we drew a diagram. In here you find something called structure mapping and transformation. Structure mapping and transformation. So this is what structure mapping and transformation. You can map, you can transform. You can make modifications to the table structure, and we can write an ABAP code to transform data. Like you want to skip few records. You do not want all the years to be transferred. You only want a specific year. Okay, transfer only for data for the current year from January. You do not want any data that is changed in last year. So these business rules we can write in SLT using ABAP include programs. So whenever you change the structure of the table in SLT, the structure of the table does not change on the source system. So this is same. They're not making any modifications to the source structure. We are only making the modifications to the table in the SLT structure. So this we do it in IUUC REPL_content. So let's go back. If you want to delete columns which you don't require, for example, I may not require all the columns from the table. Just like projection, I can do minimal projection, means required columns. So I can click on this remove field and click on this remove field, select and remove field, remove the field name, remove the field name. If you want to change the structure of the column, select the column, click change field. You can change the length. For example, I would give it as 20, length as 20, and click continue. So this is deviation type. Modification type is remove, change. You can click on table settings. In the table settings, you can give deviating table name. Even you can give a different table name. Suppose say you don't like the standard table name, for example. You don't like this naming convention of the standard table. You want to give something more meaningful. You can change the name of the table. I can give a different name. I can rename the table name in SLT. I can change the columns inside the table. Click Save. Save the configuration. C1 COPA table successfully updated. Click Back. I save the configuration. Now let us go back to LTRC. Let us go back to LTRC. Let us click on SVSLT 2016. The table is currently replicating. You see, when the table is being replicating, I'm making this modification. When the table is in the process of replicating, when I make these modifications, when I refresh, but where are we making these modifications? Are we making the modification on the source table, or we are making the modification on the SLT table? So there can be two chances. One, you can make the modification on the source. You can make modification on the SLT. So in this case, we are making to the SLT. So when the table is in process and you're modifying this table in IUUC REPL content, you can go back to HANA Studio, right click on the table, open definition, click refresh. You see, do you find any change in the table structure? Or even when you right click on the tables, refresh. Do you find any table called COPA table? We rename the existing table to a deviating table name, which is COPA table. I don't find this COPA table here. So when we make any modifications to the table on the SLT, we need to stop and replicate again. So when you stop, what is going to happen? When you stop, logging table and DB triggers are going to get deleted. When you replicate again, now a new logging table is created based on the structure on the SLT side. So the logging table gets modified. So why we have to stop is because the status of the current logging table is based on the modifications on the SLT server. So I'll go back to LTRC. I'll click on data provisioning. I'll stop load, give the table name, click execute, click refresh. The table is deleted. Table is deleted, but the table is not deleted from HANA. Right click on tables, refresh. Still we have the table C1 COPA table. Now when we go back to SLT server, click on data provisioning, provide the table name, start replication again. Get C1 COPA table. So let's click execute. So I'm replicating this table again, click refresh. The table has started replicating. Let us go back to HANA. Right click on tables, click refresh. Now do you see this new table called COPA table? So we see there's a new table now created called COPA table, and you also have the existing table C1 COPA table. When you right click on the table, open data preview. This is the old table. When you right click on COPA table, open definition. You see now this is the modified table. So what I'm trying to explain here is the table that we are currently getting is from SLT system. This is not from the source system, because this is the modified table where BUKRS is equal to 20, and we don't find VKORG. So when I go back, so basically this table is referencing to the base table. This table is referencing to the base table. So now when I go back to the source table, there is a source table, click display, click contents, click execute. So this is the data in the source table. I create a new entry in the source table. I'll give it as 9,099 and 900. I'll click save, click back. So we have a new entry. So let's go to HANA. Right click on the table, open data preview. So please see, do you find this new entry with 9,909 and 90? We don't find this. But when you go to the new table, right click, open data preview. So do you find the new entry? So when you're giving a deviating table name, instead of overwriting the existing table, system creates a new table. So when it creates a new table, we need to modify the views that are already existing on this table. So we have to replace the old table with the new table. Because currently if you see, if I go to the data provisioning editor, when I refresh, you see it still shows CE1 COPA table replicate in process, because this is the name of the table in the source system. The table name is same on the source system, but we change the name in the SLT system. When you make any changes to the data in the source system, this is pointing to the new table on the SLT, and SLT basically gives to HANA. So structure mapping and transformation. So you can transform, you can map columns inside SLT, you can remove, you can change, you can add, you can modify table structures. Also, you go to advanced application settings. Let's go to the advanced application setting again. Create session. Let us open the T code. Double click. Double click on configuration. Double click on CE1 COPA table. So this is the deviating table name, and this is the latest structure. If you want to see view modified table structure, click on this. So this is the modified table structure. Right click on the rules assignments. Click add table. Provide the table name. So all the transformations in the SLT is based on the ABAP system. It is either for non-SAP or SAP systems. Click continue. So this is the name of the table, rule overview. So you can create an event related rule or a field related rule. So what is the target field? You can write the implementation. You have to create an include name. What is the name of the include program? So this part will be taken care by an ABAPer. He needs to be a real expert in writing this code, which is a performance optimized code. So he writes the code. These include programs which are created by him. We're going to pass this parameters in LTRC. In the field related in assignment target, we need to give in all the import parameters, include name. If you do not want to write the include program, there is no way you can debug over here. There is no provision to debug. You can just simply insert a line of code, but there is no debugger. You can just include the code, but you cannot debug. So when you write an include program and insert over here, you can validate the program in SM38, SE38. We have a table. Let me create session. Let's go to SE11. The table name is the table name is IUUC underscore ASS underscore RUL underscore map. Assignment of rules to the table. You can assign different rules to the table. When you assign the rules to the table, here you see the code and the include name. Include name, nothing but the data element is program, nothing but the above program name. And here you see code, text line. So when your code is less than 72 character length, but still you cannot validate your code, the code is less than 72 character, you can directly insert the code over here. But if you're really sure that code is correct, if you're not sure and if it is more than 72, you can write an include program. So this part will be taken care by the ABAPers. So they will write and they will insert these required parameters. And in this case, we have to replicate the tables. So save and re-replicate the table. So whenever you make changes again, save, stop and replicate the table again. I would like to give you one more scenario over here. Now, structure mapping and transformations is your writing on the IUUC REPL content. But how about when you change the structure of the source? Whenever you make modifications to the source table, immediately those changes will be reflected in HANA in real time. Even when you add a column, when you modify a column, in real time the changes are reflected. It means that we don't have to stop the table. For example, if I go to the data provisioning editor, CE1 COPA table action is replicate, status is in process. I'll go to the table in the source I'll click back and back. So I change this table now. I click on change. Then I click on change. I add a new column, Z VV080. Add a new column. Excuse me. I click on predefined type. So now this I'm doing when the table is being replicated in the SLT system. I'm making a change to the source table. I click save, continue, and click activate, and click continue. So whatever the changes that you make, the configuration, everything is assigned to a transport request. So what changes you're making over here, all these changes, now you see just give me 1 minute please, I'm just trying to, okay. So you can go to and object directory entry in the table. So usually an SLT consultant will not modify tables and is not responsible to assign tables to transport request. Now if it is a Z table, this will be taken care by ABAPer. Usually the HANA consultant does not involve in this activity. So when you click on object directory, the current package now is $TMP. It is assigned to the local package. So later when you transport them using SE10 or SE09, so this transporting of tables, or when you make any change to the table, for example, I made a change over here. All these changes are recorded in the transport request, and when you move this request from development to quality and to the production. So during this process of moving the request from development to quality to production, we don't have to stop the SLT jobs. It is not necessary that you can stop and only then you can transport the change of the table, because the changes are done by the ABAPer, but the jobs replication is taken care by the SLT. So there are two different roles over here. One is the role of an ABAPer and the other one is the participant who is working on the HANA system. Sorry, the consultant who is working on the HANA system. So when the ABAPer moves, it doesn't have to inform to the SLT consultant, because automatically these changes will be reflected. So here we have to assign to a transport request, and once you move this transport request, once we move to the transport request, now you see I made a change. Now let's see in the SLT system. Activate this. Let me activate object generated. Once the object is generated, add a new column. But when I click on contents, click execute. Now for the new column, we don't have any data. Let's say for the last record, 9000, I change and assign a new value and click save and click back. Now you see for VV080 we have a new entry, and we also have a new column. The table has a new column and a new entry. So if I go back to HANA, and I right click on the tables and refresh, and also let us go to the rule maintenance, which is IUUC_REPL content, rule maintenance. Click on the configuration. This is the name of the table. Double click on the table. So here I'm going to show you two cases. Now you see, I did not get this VV0, ZVV0, VV080. This is the original table, and this is the modified table. So we just now insert this column. But when you modify this table again, you need to stop and replicate. When you modify this table, if by any chance you modify this, you have to stop and replicate. So simply to understand, whatever you do in IUUC REPL content, when you want to see the change, you have to stop and replicate. But when you're doing directly on the source system, I go to HANA, I'll double click on the table, refresh, it is reflecting to the original table. So here it is reflecting to the original table, because we did not maintain the rules for the original table, because we changed the name of the table. So because we changed the name of the table, that is why it is reflecting in the old table. I did not replicate the table again. But when the structure is changed, when you right click on the table, open data preview, you don't see the record. You only see the structure change. Because I have a rule on this table, when you have a rule on this table, the case 2 is we need to stop and replicate again when you have a rules on the table. When you don't have a rule on the table, it directly replicates the table. If you did not mention the deviating table name, it directly changed the base table. So in order to change ZVV080, I haven't stopped and re-replicate. I haven't stopped and replicate the table. Automatically system can take care. But one important point here is, I just want to highlight one more point over here. You can change non-key fields. You can change non-key field when it is not the key of the table. If it is a key of the table, I go to the base table again, I give the table name, click display, I click change. The best is currently editing this table. So what I'm going to do is, I'll just, so table is locked somewhere. So I think here. So this is the place it is locked. So please see now, I'm going to show you one more case wherein you're changing the, you see, BUKRS is char and the length is 10. Table is being replicated. I'll activate the table. Click continue. Click continue. Object activated. I'll also change the key of the table. Now in this case I'm changing the key of the table. Click activate. Continue. Now when I change the key of the table, let's go back to HANA. Now we have two keys over here. The first key is BUKRS and the second key is VKORG. Please see, now we do not have any key over here. For the same structure, there is a logging table generated in LTRC. Click refresh. This is the logging table. Let us open the logging table. S11. Let us open the logging table. Click display. Please see, when I display the logging table, how many keys do we have in the logging table? It is JetBUKRS is the key. And this is wrong. Because in the base table, if you notice, there are two keys, BUKRS and VKORG. But in the logging table that you notice, when you notice, you see only there is one key. So this creates an inconsistencies when replicating the data, because the base table has two keys and the logging table has one key. Because we change the key in the table. So in scenarios similar to this, whenever you change, if you change a non-key field, that is fine. It doesn't have much impact on the system. But when you change the key fields, obviously the logging tables also need to be adjusted. So in order to adjust these logging tables, always the best practice is to stop and replicate again. Always you need to stop and replicate the table again. So I open the definition. I click refresh. I change the definition here, but still the key is not reflected in the target. A non-key field when you change is reflected, but a key field when you change is not reflected. So for this scenario, in cases of changing the key fields, the best practice again, even for the source table, even when you're making a change on the source system, go to data provisioning, stop load, execute, click refresh. Click on the data provisioning again. Start replication again. Click execute. So this time when you replicate, the logging table is created. Jet C1 COPA table. If I go back to HANA, so the new table in the SLT. Let's click back. The logging table, we need to delete the rules. So once you delete the rules, let us delete the rules. I think the logging table name is SE11 612. Click display. So two tables have keys now. One is BUKRS, the other one is VKORG. Now in this case, the logging table is changed based on the source definition. But because in the rules that you define, in the SLT rule that you define in IUUC REPL content, you see in the rules that you define, when you open the table, click on the table structure. Please see the key is in both now. Both BUKRS and VKORG. So when you change the, now please see I don't have this column over here. That's why I cannot display them. I cannot display this field because I put remove over here. If I display this column, I go to change. I'll delete this rule. I'll delete this rule. I'll click save. I'll click back. Now please see I save the rule to display this column. You see in COPA table, I click refresh. I see the new rule. So we don't see the new rule, but we can see the new column VV080 because I replicated the table again. Whenever there is a rule, you need to replicate the table again. So now I go back and stop, and I stop, execute, data provisioning, start replication again, execute, refresh. So I'll just try to conclude this. I'll conclude this. So in refresh now, you go back to the table, open the table definition. Now VKORG with the second key. So because we have defined a rule not to display, that's why we are not able to see this column. So when you change, when you delete the rule on VKORG, we can see the key. So the conclusion that I want to make over here is, whenever you change a non-key field, automatically the column is reflected in HANA. But when you make a change on a key field, the logging tables are still the old logging tables. In such a scenario, you have to stop and replicate the table again so that there are no inconsistencies in the logging table and the data being replicated to HANA. Just one point over here we need to remember is when you change the key field, make sure that you stop and replicate the table again so that the same changes can also be reflected in the logging table, and based on the logging table it points to the HANA table. That is the only point I would like to highlight. Non-key fields, system take care. Key fields, developer take care. So let me recap what we have seen in today's session. So in today we are discussing about various scenarios regarding SLT. First is whenever you stop, logging tables and DB triggers are created. When you start again with the same structure, logging table is available with the same technical name. You can make modifications to the table structure using IUUC REPL content decode, where you can change columns, you can rename columns, you can change data type, add new. You can transform data by using above include programs. You can write a code if the code is less than character 72, and this will be taken care by ABAPer. So once he writes the code, he informs us to replicate the tables. So whenever the changes in the SLT system is made, we have to stop and replicate. Whenever there is a changes in the source table, automatically system takes care for non-key fields. For key fields, a developer should take care. So this is today's session. Any questions on today's session? Please write down your questions in the chat box. I will read your questions and answer your questions. Thank you. So I think most of the questions are administrative related questions. So we'll continue the session tomorrow, again, same time at 7 a.m. in the morning. Thank you everyone to attend today's session. I'll see you tomorrow, same time. Thank you.